This project is missing the tag cable. Didn't come with one, I don't have one. Same way, we're missing speedo cable. Speedo drive on here seems to be good. Well, seems to be good. This 7-volt voltage regulator is toast. I'm not sure if any of this works, if these are good or not. So the best thing we can do, build ourselves our own dash. How hard can it be? So you may ask, how the hell are you gonna build the instrument cluster? So here's my genius plan. We're gonna take a Nextion display, which is TTF and even touchscreen, that only needs 4 wires, basically a serial interface to communicate with it. So that's our display, and then we're gonna take an Arduino, or in this case the plan is to take an Arduino Nano, basically a small microchip computer with a bunch of inputs. Focus. With a bunch of inputs. There you go. And outputs. Hook the two together. Some other parts. And we make an awesome digital dash. So let me take you to the computer and show you the schematics. So here's the schematics. Well, the plan changed just a little bit from the original one. I didn't have enough input pins to get everything I wanted in it, so I made the decision to use just the microchip from the Arduino at Mega 328. Yeah, at Mega 328 chip. And actually I needed a GPO expander, basically a port expander. So let me bring you closer, so maybe not that close. Okay, here we go. So this is our CPU, and this is our port expander. This is the connector. So basically I have 15 inputs plus ground, plus 12 volts, plus 12 volt ignition, and also 5 volts out. So let's run through the things. This is our power supply, basically a voltage regulator, converts from 12 volts or 14 volts when we're charging to 5 volts to feed all of this. Some capacitors. This is a solid state relay. Basically the idea is the constant 12 volts come in through this input into the relay, but it's open. So when the ignition gets turned on, we turn on the power through this. Relay opens, we get 5 volts. This also, the CPU will be holding the power on. So when the ignition is turned off, we can save some information about the trip, averages, and things like that I can code. So that's the power supply end. So this is the chip that needs just an oscillator and 2 capacitors to run. This is a port expander. We are talking on a 2-wire interface, I2C to it. The same way to... This is a real-time clock chip. Again, needs an oscillator and 2 capacitors, and that's it. So this microchip will tell us the time, day of the week, and all that jazz. Port expander, nothing more, right? A bunch of inputs and outputs, and you talk to it through the 2-wire interface to figure out the state of those connectors. These are optocouplers. So basically we have 2 types of inputs, right? Like for example, the gears 1 through 5th, including neutral, right? 1, 2, 3, 4. You know, we kind of hook them up directly to this because they get pulled to ground when the gear is selected. Otherwise, that wire is not connected to anything. So we can detect that directly with our digital input, so to speak. It's either 0, it's either 1, so to speak, always 1. Otherwise, it's 0 when it's pulled to ground. So when 0, we know that that's the gear is selected. And we have an optocouplers for 12 volt inputs like ignition, left turn signal, right turn signal, and high beams. So that's these basically optocouplers like relays, but less powerful. So we're just trying to detect the presence of voltage. So that's basically it. This is a programming interface connector, and this is the connection for our display. So the schematics is really simple, nothing to it. 4 optocouplers, a bunch of resistors to break down the current to the level that our optocouplers can support. And one thing else, here we have a voltage divider on the ignition, on plus 12 volt ignition. This will detect the battery voltage if we're charging or not. Oh yeah, and these two are also basically voltage dividers. Will feed plus 5 volts and one resistor, and the other resistor is either the water temperature sending unit or the fuel level sending unit, which is basically a variable resistor. So through that variable voltage on these inputs, I'm gonna figure out what level the tank is at or what temperature the coolant is at. So that's it in terms of schematics. Pretty simple. Once we ditch the Arduino, it shrinks a lot. So now let's build it. So here we go. We have assembled this part of the circuit, which is the power supply. We have the basically solid state relay, the voltage regulator, some caps, diodes. So basically, let's get the power on. We have ground and we have battery 12 volts. You can see output is nothing. So if we get the ignition 12 volts, our solid state relay fires, and we have 5 volts to power the rest of the circuitry. We remove it, the relay drops, we cut the power. Now I'm gonna put in the expander and the CPU in here and wire it up and get you back. So here we go. We assembled our device, hooked up through the programmer to the computer. Now let's try and read the configuration bits. Oh, okay. Well, we need to turn on the power. Hey, light is green, so we're making 5 volts. We tested this before. Let's do this again. Read. Okay, so we're not able to communicate with this chip, and I had it previously in the breadboard and we were able to communicate. So everything is right with the world, because the rule is if you assemble your project, you plug it in and it works, there's something fundamentally wrong. So this one is not communicating, so I made a mistake somewhere. So let's shut it off and go hunting. So I think I found my problem. I have the 2 connectors hooked up wrong. So that's the top. That should be a meso. That should go here, not to the first. So I think I need to switch these 2 wires around. These 2 around. So let's get the soldering iron up and running, and let's try and switch them around. Hopefully we'll get that done. So miso is 1, 2, 3, 4 from the bottom. 1, 2, 3, 4 from the bottom. Yep, this one. These need to be switched around. Switched around! Okay. We have it switched around. Let's see. Let's hook this up. Positive, negative. Power. So we have power. Come back here. Read complete. Okay, cool. We're communicating with the chip. Hooray!